Thank you very much. Yeah, so my name is Jeff Brown. I'm one of the co-founders of the Grails framework and am the Grails practice lead at OCI. As most of you know by now, about a year ago, OCI became the new home to Grails. So about a year ago, we got started with the practice at OCI, and at that point there were two of us on the team, and that is Graham and myself. And in the first year of having the practice at OCI, we've grown the team from the two of us to 12 of us currently on the team, and we're hiring. So if you're interested in doing Grails work, send us a note at grailsjobs@ociweb.com, grailsjobs@ociweb.com, and we'd love to hear from you. We moved the practice to Grails, as I said, about a year ago, and things are going just fantastically well. In the first year, as I said, we've grown the team substantially and are still growing the team. In the first year, we released something like 25 releases, which has been fantastic. We made a conscious decision with Grails 3. So we released Grails 3.0 on March 31st of last year. And we made a conscious decision with Grails 3 to start releasing smaller, more frequent releases. And there are a number of benefits to that approach. And one is we can get features and bug fixes to users more quickly. So if one of us makes an improvement to Grails today, you'll probably see that in a release in a small number of weeks, maybe 3 weeks away or something like that, not months away, which is great. And another nice side effect of that approach, of course, is that it makes the releases smaller and more manageable. It's much more easy for you to upgrade your applications. The day before yesterday, we released Grails 3.1.8. So if you were on Grails 3.1.7, the update to Grails 3.1.8 is very small and simple. You could do that probably, and it wouldn't take you very much time at all to do that upgrade. And if you're consistently doing that, you never get to a point where an upgrade is a big major effort. So the smaller, more frequent releases has worked out very, very well. We've gotten really great feedback from the community about that. So we'll continue doing that. And one of the things that's enabling us to do that is we've got the full support of the company behind the framework. We're actively moving the technology forward, and it's really great to be at an organization that really truly supports us and is helping us get where we want to be with the framework. And it's been a long time since we've been operating in that mode, so I couldn't be happier about how well things are going at OCI. So the practice, the Grails practice includes not only supporting the technology, developing the technology, but also we offer professional services around the technology. So that includes Grails 3 training. We're helping a lot of clients do Grails upgrades. So if you've got Grails 2 projects that you want to update to Grails 3, we'd love to talk to you about that and help you with that however we can. And we also do a lot of project work. So for any help with professional services around the framework, please reach out to us and let us know, and we'd be happy to talk to you and help you get your applications where they need to be. Just a little bit more about OCI. So OCI has been in business for about 24 years and has been an open source company the entire time. So OCI was an open source company before it was cool to be an open source company. We've got 140-something engineers, and something like 30% of the team have PhDs or master's degrees in their fields. So we've just got a super strong team of developers at OCI. So anything at all that we can help you out with, reach out and let me know. As I said, OCI has been an open source company the entire time for 24 years. This is some of the open source technologies that we support, and Grails, of course, is where I spend all of my time and effort. This is a small subset of a lot of our customers, and really what I want to relay there is that we're targeting many industries, right? And that works out really well for Grails. Grails is a general purpose framework. It's not a framework for building aerospace applications or a framework for building financial applications. It's a general purpose web framework, which makes it appealing to anyone who wants to build web apps. And of course, that's every industry. So we work in pretty much every industry. So things are going great at OCI. As I said before, I couldn't be happier about the decision to bring the team there. It's working out very, very well. So what I want to talk about today is we're going to talk about monitoring and metrics with Grails 3. And this talk is going to be a good bit different than pretty much every other technical talk that I deliver on a regular basis for a couple of reasons. One is that I want to demonstrate some capabilities that are not complete. So we're going to talk about the Drop Wizard Metrics plugin that's being developed for Grails 3. And not a whole lot of effort has gone into developing the thing yet. I'll demonstrate what the plugin is capable of now. But one of the reasons that I want to talk about this is to solicit feedback and put some of the ideas out there and start to get feedback from the community to gather information about what sorts of things would help you get what you need out of Grails 3 applications in terms of monitoring and metrics. So as I go through this, be thinking about what pieces of this seem interesting and what would you like to be able to do that you cannot do today or not sure how to do easily today with respect to monitoring and metrics. And all the feedback that we can get around that will help us evolve this thing to make it more and more compelling. So as I said, not a whole lot of effort has gone into this plugin yet, but already it's capable of some pretty interesting things that I'll demonstrate. So as I said, one of the goals here is to get feedback and start the discussion with the community about what kinds of things we can do in this area to help you out. And another is to talk about some of the features that the plugin does support, or talking about some of the features that the plugin supports is going to enable me to talk about some really cool features that Grails 3 and Groovy have to offer. And a lot of that has to do with AST transformations. And so there are some interesting pieces, interesting things going on with this plugin that should be of general interest to Grails 3 developers. And kind of along those same lines, I'm going to demonstrate some capabilities that are made really simple in Grails 3 because of the fact that Grails 3 is built on top of Spring Boot. And that's an important point. It's an important thing for Grails developers to recognize is that Grails 3 was a major overhaul of the framework. And we re-architected the whole thing to run on top of Spring Boot. So every Grails 3 application is a Spring Boot application. There are no exceptions to that. So anything you can do in a Spring Boot application, you can do in a Grails 3 application, plus a whole bunch of other stuff, right? Everything else that Grails adds on top of that. So when folks are talking about should I use Grails or should I use Spring Boot, I think a good way to think about that is should I use Spring Boot alone or should I use Spring Boot with all this other cool stuff that Grails has to offer? That's really the way that I look at this. So I'll demonstrate a couple of features that are specifically coming from Spring Boot that relate to monitoring and management and so forth. And that'll demonstrate or support the point that I just described, and that is Grails 3 is built on top of Spring Boot, and that's important. The reason that we decided to build Grails 3 on top of Spring Boot is this really powerful, really flexible platform that offers all kinds of cool stuff that is enabling us to do even cooler things in Grails 3. All right, so we're developing a plugin called the Drop Wizard Metrics plugin. So this is a Grails 3 plugin that kind of sits between your application and the Drop Wizard Metrics library. And I'm going to talk a little bit about what the library is capable of. We're not going to get into super low-level details about Drop Wizard, but I'm going to introduce a couple of capabilities that the library has to offer, and then take a look at what it looks like in a Grails 3 application to take advantage of some of those capabilities. And that'll enable us to talk about some of the things I mentioned before, some Groovy features that Grails takes advantage of to really help with the developer productivity gains that Grails has to offer folks. So installing the plugin is super simple. Like any other Grails 3 plugin, in your build.gradle file, you have to express a dependency on the plugin the same way you would express a dependency on any other jar library, right? So you can't tell from looking at that line of code there that this is a plugin, other than the org name happens to be org.grails.plugins. So that's a hint. But the syntax for expressing a dependency on a plugin is exactly the same as the syntax for expressing a dependency on any other kind of library in a Grails 3 application. So one of the major things that changed in Grails 3, separate from us re-architecting the framework to sit on top of Spring Boot, is we removed our own build system that was part of Grails 2. In Grails 2, we had our own build system that was kind of built on top of, or at least took advantage of, technology called Gantt, which was a tool for enabling easy access to ants from Groovy, basically. It's a little bit more than that, but basically it was that. And we built our own kind of, our own build system on top of that. And it was sufficient for building Grails applications, and it supported us for a long time, but it really wasn't a full-featured, well-rounded build system. It was a pretty narrow build system specifically written for Grails. One of the things we changed in Grails 3 is we got rid of all of that and built our stuff on top of Gradle. So now you get to take advantage of all the great stuff that Gradle has to offer, and here's an example of that, right? There's no special mechanism for installing a plugin. You're simply expressing a dependency on a library the same way you would express any dependency with Gradle. So that's good. So the plugin is called Drop Wizard Metrics. You see I'm using a build snapshot. As I said, this is still early in development, but that's what the dependency would look like if we were going to take advantage of the plugin today. So one of the ideas that Drop Wizard supports is Drop Wizard has the notion of a meter. So one of the things I can do with a meter is measure the rate of events over time. So there's some built-in support for tracking averages on 1 and 5 and 15-minute intervals. So if I've got a meter in my application, whatever it's metering, I can look at that meter and find out how many times has this thing happened over the last 5 minutes, or what's the average time it takes these things to happen over the last 5 minutes or 15 minutes or so forth. So that quote there, that's the description that the Drop Wizard library itself uses to describe their idea of a meter. So we're measuring the rate of events over time, like requests per second. So in a Grails 3 application that's using this plugin, one of the things you can do is you can write a class like this sum class that you see in the lower right there that implements meterable. So it looks like meterable must be an interface, or might be an interface, but meterable is actually a trait, right? Groovy has support for traits. A trait is like an interface and it's like a class, but it's really neither of those things. A trait is like an interface in that you implement it the same way you do here, but it's like a class in that you can have real code inside of the methods that you declare in that interface. So you can define behavior in a trait, and then when a class implements that trait, all of the behavior that's defined in the trait is brought into this class. So it's like inheritance, right? So if meterable were a class and some class extends meterable, then some class would inherit all the behavior that was defined in meterable. But an important distinction between a trait and a class is you can only extend one class, right? Just like in Java. With Groovy, every class has one parent class. You can't extend two different classes. But you can implement any number of traits. So there's a meterable trait provided by the plugin, and what the meterable trait does is, one of the things it does is it provides a method called markMeter. And the way to take advantage of that method is you simply call markMeter and pass the name of the meter as an argument. So you're passing a string to the markMeter method. And what that does is it increments that meter, right? So you're keeping track of how often does this method get called. So one of the ways to take advantage of that feature is as simple as what you see here, right? If you've got a class that wants to meter something, that class can implement the meterable trait, and then inside the class, when you call markMeter and pass a string as an argument, that increments that meter, right? So it could barely be simpler to take advantage of a meter. We're going to look at another way to take advantage of a meter, but that's pretty straightforward and simple. And that's an example of Grails making it very, very simple to take advantage of frameworks like Drop Wizard. So we don't have to mention Drop Wizard inside of the sum class. We don't have any tedious code that's going out to the Spring application context to get the metric registry. That's what's happening, but it's all happening inside of the trait, right? So there's code inside of the meterable trait that handles all the complexity of going out to the Spring application context, getting the metrics registry, finding this meter, incrementing the meter. All the stuff that has to happen is happening via code that's provided by that trait. And now the code that you're writing is made super duper simple, right, as you see here. And the unit test over there on the left demonstrates testing this class, right? So notice that test is annotated with @test mixin Grails unit test mixin. So I want this unit test not just to be a standard Spock spec. I want it to be a spec that is kind of Grails environment aware. And that's what the Grails unit test mixin does. And one of the things I can do as a result of that is I can define beans that get added to the application context that's used when this test is running. So the bean that's being added there in that static do with spring block is a bean called metric registry, and it's an instance of the metric registry class. It turns out, so that's a drop wizard class. And that registry is where all the meters and timers, it's kind of it's the place where all the drop wizard stuff lives. And the reason that I need one of those in the Spring application context is the code that's inside the meterable trait. The way that it's doing what it's doing is it's going out to the Spring application context, finding the registry, and then interacting with it, right? Going to the registry to get the meter. So the code in the meterable trait needs to be able to interact with the metric registry. So the metric registry needs to be in the Spring application context. And the way that Grails 3 unit testing stuff works, it's super easy to add stuff to the Spring application context. And that's what's represented in that do with Spring closure there. So then what's happening here? So in the test, we get a reference to the registry out of the Spring application context, and then create an instance of some class, interact with it a few times, and then just make an assertion that the timer count is what we expect it to be. So we're testing that the sum action method really is incrementing that meter count. And in this case, we're only making a claim about the count of times that the meter has been incremented. In your real application, and we'll see an example of this coming up, you can discover the counts, you can discover averages. There's more information that you can retrieve from that meter than what's demonstrated in this test. But I wanted to demonstrate how to, when you're unit testing code that's using the meterable trait, the example you see here is a good way to go about that. And the important part is that that metric registry has been added to the Spring application context. All that makes sense? Any questions about any of that? Great. So another way to take advantage of drop wizard metering is with an annotation that the plugin provides. So the trait that I just talked about comes from the plugin. That's not from drop wizard. And this annotation also comes from the plugin. So here we've got a class called SumMetered class, and it's got a property in it of type metric registry, and the property name is metric registry. And we've got a method that I want to meter. So if I were going to interact with drop wizard kind of directly, the code you see here is how I might do that. So I would register an instance of this class, the SumMetered class, as a bean in the Spring application context, and configure it to participate in dependency injection. So the metric registry property will be initialized by Spring. So something's got to add that metric registry bean to the Spring application context, and that will enable this class to get a reference to that metric registry by way of Spring's dependency injection. So we've got a reference to a metric registry before this method executes. And what the method is doing is creating a name for this meter. And there's some overloaded versions of the name method, but we'll just say that the meter is called SumMeter. It's good enough for our purposes here. So I've got a meter name. Then I want to retrieve the meter from the metric registry by that name. And then I want to mark the meter, right? So all that stuff is happening automatically when you implement the meterable trait. This is what it might look like if you weren't using the meterable trait. But that demonstrates what's really going on under the covers. If you annotate a method with @metered, which is, again, that's an annotation that's provided by the plugin, you can do something like this: @metered, and then pass a meter name as an argument. There are other optional attributes that affect how the meter name is actually created. But I can annotate a method with @metered, provide a meter name, and that's it. So there's no code here that makes mention of the metric registry. There's no code that talks about meters other than the metered annotation. And now the sum action method there will be metered the same way that the sum action method that you see on the left is metered, right? But you don't have to write any of that code. It's all added by the plugin. And how it's added by the plugin is interesting. So we're able to rig all of that up at compile time. So the @metered annotation has an AST transformation associated with it. So Groovy supports AST transformations, and an AST transformation, in short, is code that you get to write that participates in Groovy compilation. So you've annotated this method with @metered. That tells the Groovy compiler that when this method is compiled, go execute this special AST transformation that's been associated with this annotation. And what that AST transformation is doing is it's generating all the code that you see on the left, right? The AST transformation is doing all the stuff that it takes to go get a reference to the registry, get the meter, increment the meter, all that's happening. All that code is being added to your class at compile time, but you don't see that code in your source code, right? Which is good. In general, code is a liability, right? You want less code, not more code. And having this declarative approach, as opposed to writing imperative logic inside of your method, you're declaratively expressing that you want this particular method to be metered. And you don't have to know about the implementation details of how that works. You don't really have to understand how to interact with Drop Wizard. And if the implementation changes in the future for some reason, your code stays exactly the same, right? You've written code that annotates a method with @metered, and the stuff that's in the background there on the left is all generated for your compile time. So if in some future version of the plugin, that code that's in the background changes, fundamentally different things have to happen there, that doesn't affect your code, right? So we're able to do that sort of thing because of Groovy's AST transformations. And that same approach is used all over the place in the Grails framework. We apply AST transformations to all of your artifacts, so domain classes have transformations applied to them, services, taglibs, controllers, quartz jobs, lots of things in a Grails application have AST transformations associated with them. And so this is an example of taking advantage of that feature offered by Groovy. Any questions or comments about any of that? All making sense? Good. Another notion that Drop Wizard supports is a timer. And again, I've quoted how the Drop Wizard documentation describes a timer. So a timer is a histogram of the duration of a type of event and a meter of the rate of its occurrence. So where a meter, we can simplify a meter by just saying it's sort of counting how many times something happens. A timer is doing some different things, right? A timer can tell you not only how often did something happen, but how long does it take to do that something. So here's some code that one might use to take advantage of a Drop Wizard timer. So we've still got to get a reference to the metric registry. We'll go to the registry, or we'll create a name for our timer, go to the registry to retrieve that timer, and then effectively I need to start and stop the timer. So when I call timer.time, that kind of puts the timer in motion, and then at some point I want to stop the timer, and you see that in the finally block here. So all of your logic, whatever really is supposed to be going on in the SumAction method, is all inside of the try block, and everything you see around that is just kind of overhead. That's the cost of taking advantage of the Drop Wizard timer. It's not horrible, but there's some code there. So just like the @metered annotation, there is an @timed annotation that behaves the same way, right? So I can annotate a method with @time, provide a timer name, and now at compile time, the plugin will add all of the code that you see in the background to the method that's been annotated with @time. Kind of more of the same, right? Does all make sense? Any questions about any of that stuff? All right. Let's go take a look at a demo application that I've got set up here. And we'll take a look at a little bit of the code that's in this application. So I've got a controller called Artist Controller that is managing instances of this artist class. So the details of the domain class are not particularly important, but I've got a domain class. An artist has albums associated with it, and I've got a RESTful controller here for interacting with instances of that artist class. And notice that I've overridden the show method that is inherited from the RESTful controller class, and I've annotated that with @metered, and the meter name is show artist. So I want to keep track of how often the show the show action in this controller is invoked. So I annotate the method with that meter. Separate from that, I've got this service called metrics logging service. So this is a Grails service, right? It's declared under Grails app/services. And what the service does is it provides a method called log metrics. And what the log metric method is doing is going and retrieving a meter from the metric registry, grabbing the 1 minute rate, right? So what's the average number of times the show artist meter has been interacted with over the last minute? And if that rate is higher than some number, log a warning message. Otherwise, log an info message. So the logging here isn't the interesting bit. It just makes it easy to demonstrate what I want to talk about. The idea is you could have logic inside of this log metrics method that does something if your application exceeds some threshold, right? So if your application's up and running, and periodically you want to sort of take a look at the load of some particular part of your system. How often is the show action being executed in that controller? And if that rate exceeds some threshold that you get to define, then you can handle that however you like, right? Maybe make a call out to some service that automatically spins up another instance of your app, and now you're dynamically growing your cluster. But you get to respond to that condition however you like. You also get to define the condition, right? So I've got a property called high volume threshold. So what I'm expressing there is if at any point the rate of requests that are coming into this show action, if that point ever gets above 10 requests per second, then I want to do something, right? So that's what's demonstrated here. And then I've also got setters and getters for setting that value and interrogating that value. So this metrics logger service has a property called high volume threshold, and I want to be able to set that threshold. And I'll talk about this managed resource and managed attribute annotation in just a bit. So far what we're concerned about is we've got a class that can inspect a particular meter and do something based on the condition of that meter. That's really all that's important so far. And then a last piece of this that I need to introduce is there's a quartz job that I've configured in the application. So quartz is a really sophisticated, really powerful job scheduling library. So if you want something to happen every 3 seconds, or every Friday night, or every day at noon, you've got lots of complexity around, or lots of flexibility around how you schedule jobs. Quartz makes that very, very easy to do, and we've got a Quartz job, which makes it even simpler to take advantage of what Quartz has to offer. So here's a Quartz job that I've set to trigger every 3 seconds. So that syntax you see there, repeat interval, colon, 3000, that's what's expressed there. Every 3 seconds I want this job to run. And what the job is doing is this, right? It's calling that method in the metrics logger service that we just looked at. And that's what's resulting in the output that you see down here. Hopefully that font down here is big enough you can see, but it's outputting a rate of 0. Remember what we're tracking is how often is the show action in that controller being interacted with, and it's not being interacted with at all right now, so the rate is 0 requests per second. All right. I'm going to start up a tool called JMeter. How many of you are familiar with JMeter? Yeah, most of you. That's good. JMeter is not a Grails tool. It's not a Groovy tool. It's just it's written in Java. It's a tool. One of the things you can do with JMeter is put an application under load, and that's what I want to do. So I'm going to open this test plan that I've got pre-created, and I'm going to stop this app. I want to restart it just because I want the average to quickly get up, and it's been running for a while now, so it'll take it'll take a while for the average to increase because of all the time it's been running. So I just stopped the app. I'm restarting it. And then as soon as it starts up, I'm going to press play in JMeter, which is going to put this application under load. So we'll start to see that meter increase. Now, let me get this so we can see both of these at the same time. All right, so the application's running. Let's get JMeter operational here. And after 2 or 3 seconds, we should start to see that rate in the background. There we go. So it's 0.12 requests per second, and that number will slowly start increasing. And our threshold right now is 10. So if that number gets above 10 requests per second, then we'll switch into the mode where we're logging a different message. So if I leave that running long enough, it'll get to that point. I'm going to leave it running, but I want to introduce another idea while that's getting there. So right now we're at about 1 request per second. So I mentioned earlier that we get back to that managed resource and managed attribute annotation. So our metrics logger service is annotated with managed resource, and the set high volume threshold and get high volume threshold methods are annotated with managed attribute. So let's take a look at what that means. All right, so we're up to 5 requests per second so far. Come out here, create a new one of those. So I'm going to start up GR8Console, which comes with the JDK, and it's a mechanism for interacting with NBeans that have been published using JMX. And an effect of having annotated this class with managed resource is an NBean will be created and registered, and these methods right here will be registered in that NBean, or that NBean will register these methods as corresponding to attributes that we want to be able to manage through JMX. So let's see what that looks like over here in the GR8Console. So if I look at our NBeans under metrics demo, which is the name of our application, I see metrics logger service, right? And all I had to do to cause this NBean to show up here is annotate that class with that managed attribute. And so there's not a Grails 3-ism at play there. That's all coming from Spring Boot. Spring Boot makes it really, really easy to register NBeans, so we're taking advantage of that. So here is the metrics logger service NBean, and if I were to look at the attributes that the thing has to offer, the high volume threshold is showing up here, and we see it has a value of 10. If I look down here under operations, there's an operation called set high volume threshold, and there's an operation called get high volume threshold. If I were to call get high volume threshold, we see the value is 10, right? Let's go back and look at the state of our application right now. So we're up to, we're above 10 now. So look right there, you see the crossover. And if the font is too small to read up there, you can at least see that the lines are longer now. That's because we're seeing a different message. This says high volume. So we've crossed over that threshold where before we were simply logging rate. I go back, that's this business right here, right? So if the rate is above 10, log a warning that says high volume, and if otherwise, log rate. So right there is when we crossed over and went into the red. So now we want to spin up another instance or do whatever it is that makes sense for our application to respond to that condition. I've got that NBean set up so we can dynamically interact with our application while it's running to not only interrogate and discover details about that threshold, but we get to control it, right? So we're up to 11 requests per second, I see in the background, and our operations people have been notified, and they decide, okay, everything's cool. The right thing to do is just to change the threshold right now. So I'll turn the threshold up to 15. All right, there we go. And that should send us back into normal operating mode, and it did. See, the logging message just changed. And while that demo seems trivial and maybe not particularly interesting, because all we're doing is logging messages, really the possibilities associated with all of that are really quite powerful, right? With very, very little effort from the application developer's perspective, we've accomplished a number of interesting things. One is that in a very simple way, we've introduced introduced access to a really sophisticated metering mechanism. We simply annotated that method with that metered, and now we get all kinds of good drop wizard capabilities associated with this class. Another is that it's very easy for us to write something that can react to conditions associated with that meter, right? So I've got a quartz job that's calling into this service every 3 seconds, and this service is interrogating that meter, looking for some condition, and we're just logging a warning versus logging info. But as I said, so this line right here, instead of logging that, and maybe an additional logging that, we could be making calls to our operations center, making REST calls to our operations center, doing what we can respond to that however we like. Maybe we don't have to have any communication with any external service, but maybe instead what would happen here is the application would go into some other state, right? So maybe there's some capability in our application that can be at runtime be turned on or off. And we've crossed this threshold, so now we'll set the flag to turn something off. Or, well, the point is we get to respond to those these conditions however is appropriate for this app. And then the last piece is what it took to expose access to that high volume threshold over JMX is really, really simple, right? All I had to do was annotate the class with managed resource and optionally annotate these methods with managed attribute. And now I can interact with that thing as an NBean without really writing any JMX code, without writing any drop wizard code, without writing any Quartz code. We're taking advantage of all of those libraries, and we've got lots of interesting capabilities as a result of that. All that makes sense? So, as he said, the sample that I'm demonstrating here is trivial. All we're doing is putting the thing under load and logging different messages. But hopefully it's easy to kind of see the possibilities and how simple it was to get access to those possibilities. Thoughts or comments or concerns about any of that stuff? Yes. You said, may we have a quick look at the test plan for what? What? Oh, the test plan for JMeter, yeah. So what the JMeter test plan is doing is I've got a loop controller here. Let's see, here's our simple controller. What the simple controller is doing, where do I see the request? Right here. We're sending a request to, and I don't know how to increase the, you know what, I can't increase the font, but I can do this. Right, we're sending a request there to /artist/artist counter. And artist counter is this variable that, this counter that I've set up in the test plan that goes from 1 to 49. So for some reasons that relate to some development work that I'm doing with the plugin, I wanted to not send the same request over and over again. There's some caching going on. What I wanted to do was retrieve a different artist, you know, so I could steer around some caching issues. I really did want to make sure some queries were being executed. So I've got an artist counter here that goes from 1 to 49. There's some code in the bootstrap of this, where is it? Right there. Right there. That's creating 50 artists. So I've got a loop here that's creating 50 artists. So 1 to 49, actually probably 1 to 50 would work. But so there are that many artists out there. And what this test plan is doing is using this counter to go from 1 to 49 and send a request like that. So I'm retrieving different artists each time. And I've got, let's see, there's another piece of this. There is, yeah, maybe that's, it's not in this version of the test plan. So that's really all the test plan is doing, is it's doing this over and over again. /artist/1, /artist/2, all the way up to 49 and back. And I can tweak this. I can do something like, if I change this number, let's see where we're at right now with respect to, so it looks like the thing is leveled off at about 11.5 requests per second. So let's stop the plan here. I'm going to cut this sleep from 3,000 to 1,500 and start it up again. So that should increase our requests per second. So we had leveled off at about 11.5. It's going to drop here for a minute just because I stopped the JMeter momentarily, and it should start increasing there. We're back up to 11.9, up to 12. So JMeter is just really, really super slick stuff. Makes it very easy to create load for your application. There's lots of flexibility in JMeter. I used it in this demonstration just because it's a simple way to create some load for my application. How many of you use JMeter in your day-to-day? Yeah, good stuff. So I'm no JMeter expert. I sort of fumbled around just enough to make that work. There might be more efficient ways to create that test plan, but it works for what I'm using it for. Other questions or comments about any of that? Yeah. Is it easy to aggregate meters across instances? So that's really what's going on here, right? So the controller happens to be a singleton, but it wouldn't have to be. If it weren't a singleton, this would still work. What's happening every time this method is invoked? So imagine that the controller is not a singleton and there are 30 of them, and they're all being interacted with. So we're calling the show method on all these different instances. Yeah, so I think the question is it, what does it take to aggregate meters not across instances of this class, but across processes, right? And I don't know the answer to that. I don't know if DropWizard has some sort of mechanisms to support that or not. There's nothing in the current version of the DropWizard metrics plugin that contributes to that at all. So it could be the case that DropWizard has some support for that. We just haven't gotten to, but I don't know the answer to that. Yeah? Yeah, so the question is, can I use this to keep track of how long something is taking? And a meter won't help you with that, but a timer will, right? So a timer keeps track of how long it takes to do something. So this particular timer, the timer you see here, would tell us how much time is being spent. Really, it's telling us how much time is being spent in this try block. But the overhead around it is probably going to be noise. So effectively, what I'm doing is keeping track of how much time is spent in the sum action method, right? So a timer will do that. That's not what a meter is for. A meter helps you keep track of something like requests per second. A timer helps you keep track of how much time is being spent in this block of code. And they get aggregated, right? So it's not how much time was spent on this particular invocation. When I retrieve that timer from the metric registry, I can discover, I'm not looking at details about a particular invocation of this method. I'm saying how much time is being spent in this method. So if there have been 1 million occurrences of calling this method in the last whatever time period, I can know how much time was spent, what's the average time, and I think I can interrogate the min, the max, the mean. I can discover details about how much time is being spent here. So I think what you're asking about is a timer is good for that, but a meter wouldn't help you with that. There's another hand over here. Any other comments or questions about any of that? Thoughts? Seem simple, seem complicated? Simple, that's the right answer, right? Like many things in Grails. Yes?
You have illustrated how you can programmatically get to the information you collect. Is there any tooling or any way to get an overview, like the operations, for instance, to see how the
Yeah. So the question is, so I've demonstrated how to programmatically get access to some of this data. Is there a good mechanism, or is there a mechanism to get kind of an overview of the whole picture of what's going on? And so maybe I owe you a beer now for bringing that up, because that's a fantastic question. Yeah.
I think that tool is a plugin called Java Metadata, the Java application, and there's also an existing plugin for Grails that I use in production, just to get an overview of how long the method takes, and you see that hotspots, and you also see the queue time. Java Metadata. Yeah, that's a base plugin also.
Yeah, so another interesting component here is a thing that we've got in the works at OCI that hopefully we're a small number of months away from being able to share a lot more details about. But we're working on a product called that we're calling Continuity, and Continuity is going to be a dashboard and management console that provides all kinds of compelling stuff from for a lot of folks from a DevOps perspective. So you'll be able to manage, to monitor and manage not only details like how much time is being spent in a particular method. That's one of the things you could look at, but it's really addressing a much broader scope where you can monitor the whole environment. So you can see things like how long are your deployments taking, and when deployments fail, when a deployment fails, let's say you've got a continuous deployment situation set up. When a deployment fails, which commits are the commits that are different from that deployment to the previous one? You'll be able to backtrack and find out what kinds of things are problematic. You'll be able to monitor health of applications, including details like metrics and timers that I'm talking about now. The product is called Continuity. There's not much information. It's not that it's secret, but we just haven't published a lot of information about it yet. in coming months. So hopefully we're going to be able to start sharing a lot more details around that. If that kind of thing sounds interesting to you, let me know, send me an email or contact me here this week, and I'd be happy to set up a demo or conference call with you, and we can talk about that, or sort of smaller grain details like the Grail specific stuff. But look to hear more about continuity from OCI later this year. It's going to be really compelling, interesting stuff. It already is compelling and interesting stuff. Thank you for giving me that opportunity to talk about continuity from OCI, the home of Grails. Yes?
We use a liquid-based application in Grails. Is it possible to use metrics to measure, for example, the number of events we have in the events, for example, to investigate if we need to have more configure proof, for example?
Yeah, so I think the question is, can we use these capabilities that I'm talking about to monitor, to meter or time events? Is that correct? In an event-based system? Yeah, so your events are causing something to happen, right? You've got an event, say you've got an event handler, and events come in, and that event handler is dispatching calls to other things, right? So you can be metering the event handler, you can be metering the things that the event handler is interacting with. As far as the drop wizard stuff is concerned, the fact that you've got an event-driven system doesn't really factor in there. What we're enabling you to do is monitor and gather metrics around blocks of code. And if those blocks of code happen to be triggered by events, then fine. But I don't think events factor in any particularly interesting way. If you've got ideas for interesting ways to sort of hook into or things that the plugin could do that are particularly compelling for an event-based system, I would welcome that input for sure. Do you have something specific in mind right now?
Yeah, the idea would be, for example, I'm running an application and I thought, okay, I would like to have a pool of 10 events at a time. But I have no idea if I will take them or not. Because I would like to have millions of events by seconds. And then I would like to have the metrics on the top of it, to measure everything which is happening. Because now the service on top of it, so depending on the metrics, to change the number of events I want.
Yeah, so you could definitely do that sort of thing, right? You could use something like this example here is tracking how often a particular meter is incremented. So your event handler is calling something. You could be metering that, having something monitor that meter, and that something can respond in the way you just described, right? So you recognize that this particular event is showing up 400 times per second, and that's the system is currently operating in a mode where that's stressing things, so let's start up another instance, or increase the connection pool, or whatever, you get to respond to that however makes the most sense. Is that making sense?
Yeah, you have to get smart application to grow.
Yeah, so I don't think, one thing that probably, I'd have to give some thought, but I don't think, something I don't think will end up being a function of the plugin is doing things like scaling things out and growing connection pools. That would be a piece that would take advantage of this, but separate from this. At least that's how I'm thinking about it right now. Does that make sense? Yeah. Other questions or comments? Anything at all Grails 3 related or Grails related, anything at all that I can help you with, please track me down. I'll be here, of course, all day today and again tomorrow. Thanks to the great folks for having us out again, and thank you all very much.